Hello everyone, I'm Jacob Kauf and I'm the nerd on the street, and today we are unboxing and setting up a Ubiquiti EdgeRouter 4. Alright guys, so a little while ago I made that video about my two Cisco routers that my friend Michael gave me. One of those was a Cisco 1921 router. It was the newer out of the two routers that I showed. And I mentioned that it was capable of gigabit speeds in that video, and that for that reason I would probably be using it as my primary router. Now, as you may know, I recently got my own apartment, and that included getting gigabit internet in here. And I have been using the Cisco 1921 router, which is end of life by the way, as my primary router, and I have found out that it actually doesn't support gigabit speeds in practice. You see, it does have some gigabit ports, and those Ethernet ports are physically capable of gigabit speeds, but the processor in the router, especially when you're doing NATing, which is pretty much required for home internet, the processor can't keep up with gigabit speeds. So what I've found is I'm limited to about 100 megabytes per second down, which is still way better than I've had at some of the past places that I've lived in, but it's not what I'm paying for, and it's not the best that I can possibly get. So I decided to look for another router, to actually go out and purchase one, since that Cisco one was free after all. And I settled on Ubiquiti. I've heard about Ubiquiti from a couple of different places. For one thing, I remember the Linux Action Show used to be big on Ubiquiti. And for another thing, my friend Michael, who was the one who gave me those Cisco routers, he also is very fond of Ubiquiti equipment. This is the EdgeRouter 4. It is about a year old. My package here is obviously new, but they released this about a year ago. However, it is one of their newer products. I believe it supports up to 4 million packets per second, and this thing should definitely be capable of gigabit speeds here on our home internet. So first we're going to bring the camera in and unbox it, and after that I'm going to cut to a screen recording and I'm going to configure this router. I work full-time in a network operations center, that's my day job, so I use Cisco iOS on a daily basis. However, I've never used Ubiquiti's command line operating system before, so I'm very curious to see how similar it is and how easy it is for me to use as a network administrator. So that's what we're doing. At this point, I'll bring the camera in and we'll get started. All right guys, and here we are on the desk. Like I said, this is the Ubiquiti EdgeRouter 4. You can see they sell it as a gigabit router, so hopefully it will work with my gigabit speeds. We'll take a look at the specific ports this thing has when we open it up, but on the right side of the box, we've got some stickers verifying the authenticity of the product. On the left side of the box, looks like this is just the Ubiquiti logo. The bottom just has the name of the router, the top of it also just the name of the router, and then the back has just a few words about the product. Now Ubiquiti has two lines of products. They've got their Edge series, Edge routers, Edge Max switches, and they've got a Unify series, which includes the Unify Security Gateway, which is the router, as well as Unify access points and switches. The Unify products are managed through Ubiquiti's cloud system, and the Edge products are managed locally on the device. So obviously, not being someone who likes to rely on the cloud, I went for one of the Edge models. And the Edge devices are usually a little bit higher end in terms of their performance as well. So we will go ahead and open this thing up. Looks like we should probably slide it out of the box this way. And inside our covering, we've got a very plain brown box with the Ubiquiti logo on top. Nothing else really on this box. We've got the name of the product one more time, and that's about it. So let's set this down and we will pull it open here. All right, and here it is, the Ubiquiti EdgeRouter 4. This thing is smaller, you can probably tell, than the Cisco 1921 that I'm upgrading from. And this thing is not meant to go in a rack. It does have adapters that you can use to put them in racks if you've got a lot of rack-mounted equipment. I've mentioned in past videos I don't have any racks in my apartment, and I'm not a huge fan of that form factor, so I'd rather have a small, compact desktop router like this. We've just got a little bit of styrofoam on both sides holding it in the box here, and there we go. I can hold it up to the camera. You can see all the holes in the top there to allow heat to rise out of it. This is the front of the router, so on this thing we've got our console connection. This is what we use to console into the device with a serial cable in a moment to configure it. We do have a USB port. I'm not sure if that is for console or if that's for adding NAS storage. It could be either. As you can see, we have 3 Ethernet ports built in, 3 copper Ethernet ports. And I really only need 2. I need one to connect to my internet cable modem, and the other one to connect to my switch. And all my computers will plug into the switch. So we don't need a ton of ports on this thing, but there is a third port if you do want to add a DMZ zone to your home network if you're running servers or something that you'd like to be accessible from the outside world without opening up full access to the inside of your network. And then here on the end, if I remove this covering, this is an SFP port. That stands for Small Form Factor Pluggable. And this is actually a type of port that is very common in networking. Cisco sells some switches, and Ubiquiti might as well, that are just 24 or 48 SFP ports. And basically this is an empty slot that you can place whatever type of port you want into. So if you want, let's say, a 4th copper Ethernet port, you can go out and get a copper Ethernet SFP and plug it in here. Or let's say you want fiber to plug into this thing. You can go out and get a fiber SFP and plug it in here. I don't have any SFPs right now that is above where my home network is at the moment, but very cool that we have that for future expandability. That definitely makes this a prosumer product. People who are wanting to dabble in advanced networking will enjoy that. So we've got a reset button here, one of those pinhole things in case you, I guess, need to reset the router to stock condition. On the left-hand side, we do have an indicator light here that's probably for power, and then we've got a 0, 1, 2, and 3, which are probably indicators for our 4 ports here. And we have a little guide here. These lights will turn yellow if they're running at 100 megabit speed, and they will turn green if they're running at full gigabit speed. So that's all very nice. On the left side of the product, we've got just more fan grills. Like I said, there is an adapter you can get to screw this thing into a rack. That's what those screw holes are for. On the right side, looks the same. The back of this thing has just power. So unlike my current Cisco 1921, where all the ports are actually on the back of the device and the front is just lights, this thing I will need plugs plugged into both the front and the back to use it. So not the best for desktop usage layout-wise, but that's what most of Ubiquiti's products kind of looked like, and that's normal for rack-mounted professional equipment. Just a little strange for a desktop model. And on the bottom here, we've just got 4 rubber feet that will keep this thing from sliding around too much on the desk. We also have 4 sort of plus indentations. Those are for hanging this thing on a wall if you want to do that. If I turn it around so we can read the sticker there, we've got a serial number that I probably shouldn't be showing you, and we've got a little bit of FCC compliance information there. And that is the entire router itself, so that is very cool. I'm excited to see how this thing performs. I will set it off to the side. Now we will see what else is in the box. Just this one other miniature box is all that's left. And in here, it looks like we have a little quick start guide or manual of sorts. Oh, this is just a card. This does not unfold. It's a little cardboard card here. So this is just the name of the product, just like the box I already had. And then the back of it, it's a QR code to download the quick start guide. Interesting. I kind of like that. That saves paper. Of course, that link might break years into the future, but I'm not sure if I'm going to use that thing or not. We'll see how easy it is to use the CLI when we get in there. I'll probably need to look up some sort of documentation. These are 2 screws, and it looks like some sort of rivet with each of them. I have no idea what these are for. Probably mounting of some sort, and I will not need that, but that is interesting. And then here is our power. And this cable is held by some sort of rubber band here. Yeah, this is just a gigantic rubber band. And we'll take that off, take the cover off of our plug, and if we slide our box out of the way now and bring the router back into the frame, we can plug in the power just like that. All right, and I do like at least that they gave us a 90-degree power connector. That way we can at least not have cables sticking out too far on this side. I think what I'll probably do is have this be the front of the router, even though the lights are in the back. But it would be easier for me to have this cable just going to the side and back behind my desk to the outlet on the floor. And then the back of this thing is where all my Ethernet cables will plug in. But that is the EdgeRouter 4 in its physical form. Now I'm going to cut to my desktop, I'm going to plug this thing in, and we're going to go ahead and configure it and get a look at Ubiquiti's command line operating system. All right, guys, here we are on my desktop, and I am just going to run a speed test real quick so I can show you the speed I was getting from the Cisco 1921. Once again, it's not quite as high as my actual internet speed, and I know we're using speedtest.net here. I'm actually not a huge fan of this site in particular. You can see the server that it usually chooses is Spectrum, which is my internet service provider. I don't really want to test using my ISP's own server. I'm going to choose a different location here actually. So we'll use this testing location, and I have witnessed this go as high as 800 or 900 megabits per second down when I was plugged directly into my modem. So at this point, I am going to click go, and we'll see how fast our speed is. Now I am plugged into a Cisco switch right now. It's a 5-port gigabit switch, as well as the Cisco 1921 router, and we're getting about 70 megabits per second down, so not even 100. Once again, this is not terrible internet by any means. If all of my connections were this fast, I would love that. But in practice, your actual speeds are going to be lower than what your cap is limited to. You can see we've got about 33 megabits per second up, which is very good upload speed. I have not had any issues uploading, streaming, or anything like that. But in reality, most of your connections are going to be limited to a fraction of your actual speeds, so we want this as high as it can go. So these are our results here, and at this point I'm going to minimize speedtest.net. And the next thing I'm going to do is open up a terminal, and we are going to console into my console cable, which is currently plugged into the Cisco 1921. We'll test it there so that we know everything's working. Then we'll go into the Ubiquiti router. So let's see if I remember how to do this. Sudo screen dev tty USB 0. Here we go. All right, so if I go into my console connector and hit enter a couple times. All right, my Cisco router is being extremely difficult right now trying to connect to the console. We're gonna go ahead and plug in the Ubiquiti router. Now, if it doesn't work on the console, clearly here, I'm having some trouble with my console adapter. I've tried it in several USB ports. Sometimes it works for half a second. Sometimes it doesn't work at all. I'm honestly extremely disappointed with the state of console adapter drivers on Linux, considering how, here we go. Okay, so now I can do a show run. Well, I can't because we're not enabled. Here we go, show. And my console connector's broken again. That's what I'm talking about. The Linux drivers for these console adapters are just terrible, terrible, terrible. But we're gonna go ahead and plug in the Ubiquiti router, and maybe the console connection will work better with that than it does with the Cisco device. This is a used Cisco router, so for all I know, that thing's busted. All right, so I am plugging in the console cable to the EdgeRouter right now, and that has been plugged in. I am reseating the USB cable one more time for good luck. And now we are going to access the USB console. So we should see a boot up sequence here. I'm about to plug in the Ubiquiti router. And the Ubiquiti router is now plugged into power. So we will see if we get anything. I'm taking a look at the front. So we do have a blue light on the Ubiquiti router. Looks like we are getting some very jumbled up text. You know, I wonder, I'm gonna unplug the Ubiquiti router again. And I'm gonna try plugging this console adapter into my laptop. Let me stop my screen recording. All right, and I am recording now on my laptop. This is what I used to make the video about the Cisco routers. And this console adapter worked a little bit better in that video after I eventually got it working. So let me access the console connector here, and let's plug in the Ubiquiti router again. Let's see if we get some more clear text. So I've just plugged in the power to the back of the Ubiquiti router, and I still can't quite tell if this is working better, or, I mean, obviously that's still very much. Let me look up the baud rate. All right, let's try connecting with our baud rate set statically here. So I've just turned off the router one more time, and apparently the default baud rate on these Ubiquiti routers is very much higher than the default on Cisco routers. Cisco defaults to 9600. Ubiquiti defaults to 115,200. That's what we're dealing with here. So I'll hit enter. Let's see if that works a bit better. Here we go. All right, so the baud rate was an issue there. Like I said, Cisco uses 9600 as their default baud rate, and Ubiquiti's default baud rate is about 10,000 times faster. So that's pretty neat. Here you can see we are booting up the router. And these routers do run an operating system. I think it is based on Linux. Now, Ubiquiti's software is not open source, just like Cisco iOS is not open source, which is unfortunate. But we can see here things starting up. Very cool. We've got an init system. Ubiquiti's operating system is much more modern than Cisco iOS, that's for sure. All right, so it looks like there is a web UI by default in addition to this console connection. All right, so the default username and password are UBNT. All right, and now we are in EdgeOS. Can we use a question mark here? Yes, we can. So we can show configuration all. And so this is showing us our configuration file. So by default, the router ships with Ethernet 0 configured as your 192.168.1.1 network, a /24 subnet. And Ethernet 1 is set to DHCP. So by default, you could just plug in your internet's modem, your cable modem or your DSL modem or whatever you've got. You can plug that into Ethernet 1, and then you can plug your switch into Ethernet 0, and it will just work. I don't know if we have DHCP, but the routing should just work based on what I'm seeing here with the configuration. And then Ethernet 2 and 3, they don't have shutdown in their configuration, but they don't have IP addresses. I'm gonna hit space here for our pager. So by default, there is a web GUI on this thing, and I'm actually gonna grab an Ethernet cable. I wasn't planning on recording on my laptop, but we'll make this work here. So I just plugged in an Ethernet cable to my laptop. You can see it connecting up here. The problem is the switch is still plugged into the old router and not the new router. So here's what I'm gonna do. I'm gonna plug the switch into, I actually want my private network on Ethernet 1, and I want the public network on Ethernet 0, which is the opposite of what they've got right now, what they have set up in the config. Once I get connected up to the network, you can see by default there is both HTTP and HTTPS enabled to access the web GUI in case you don't want to use this command line operating system. There is also SSH enabled by default, which is good to know. Looks like the password is encrypted within the configuration. We know it's UBNT though. We will need to change that because this is an administrator password. We do have NTP set up by default. This is much more default config than you would get in a Cisco router. Well, that's actually a very short config file, but this is a lot more functionality than you get by default on a Cisco router. Ubiquiti is a little bit more consumer-friendly, I'll say, in terms of their default configuration. So like I said, we want to swap Ethernet 0 and Ethernet 1. I want Ethernet 0 to be DHCP, and I want Ethernet 1 to be this address right here, basically. And I think I was using 192.168.0 actually for my old subnet. So let's go ahead and I'll quit out of viewing this configuration file and we'll go into configure mode. And so now we're in configure mode, which I guess is identified by this hash symbol. Set, what can we do here? Set interfaces, Ethernet, ETH0, IP. We don't want any of those. All right, I guess the first thing we need to do is delete that configuration. So we'll delete interfaces, Ethernet, ETH0, IP. If we delete that, we delete our address. Now if we do it's not show, it's just, no, it is show. Show configuration. I'll exit out of edit mode. Oh, we have to save commit. Okay, this is very interesting. So a Cisco iOS router, when you make a configuration change, it goes into effect immediately on a line-per-line basis. Whereas Ubiquiti's operating system here, you need to commit your changes, saving them, and then it does them all at once. That is very different. I will hit commit. We're consoled in here, so it's not like we're gonna lose connectivity. I'll exit out and show configuration changes have not been saved. So if I do a show configuration, no, it saved our change. It took away the address that was configured there. So we'll go back into configure, and now we will set interface Ethernet ETH0 address DHCP. And we'll commit that and exit. Now if we do a show configuration, you can see we have set DHCP on Ethernet 0. So now we need to delete DHCP from Ethernet 1 and then set the IP address we want on there. So we will configure, delete Ethernet, nope, interface, Ethernet, ETH1 address, set interface, Ethernet, ETH1 address, and we don't want DHCP. What if we do IP here instead? No, that's not what we want. We want address. I don't want DHCP. Can I not just type in an address? 192.168.0.1/24. It took that, commit, and it stopped DHCP. So now if we exit and we show configuration, okay, so it did put our address here. All right, so now I'm going to plug our switch, which the laptop is plugged into the switch. I'm plugging the switch into Ethernet 1, which we just set up to be 192.168.0.1. So at this point, I'm going to disconnect and reconnect the laptop from Ethernet. And let's just make sure I'm using the proper connection here. Edit connections. Ethernet connection 2 is DHCP, but this has an additional DNS server. I'm going to change the name of that connection so I know not to use it. And Ethernet connection 3 is manual. Ethernet connection 1 is shared. So we're going to create a new Ethernet connection here that's just blank. So this is going to be an Ethernet connection. I'll call this DHCP all. So this is not going to do anything except grab DHCP config from the router. So I will connect to DHCP all. And let's see if the router, it had, or I assumed that it had a DHCP service running on Ethernet 0. Maybe that was a false assumption. Maybe we would have needed to set our computer's IP address manually. But it doesn't look like there's one running on Ethernet 1. So let's see if we can set that up. So configure, set, service, DHCP server. Oh, it told me that I'm connected now. Are we actually? We are, 192.168.0.2. So we actually, I didn't need to run anything. And if we do a show, let's exit configuration mode, show configuration. Do we have a DHCP server running already? No, there's not one running. So I'm not sure how we just got connection, but I'm going to access 192.168.0.1. It does go HTTPS by default with a self-signed cert, and EdgeOS is the name of the operating system. I keep referring to the Ubiquiti operating system, but it's called EdgeOS, and here is our login screen. So I'll log in here. And this is what the graphical user interface looks like. If you don't want to use the console, which I'm still over here clunking around on the console, but this is what the web interface looks like. You can see the status of your interfaces, looks like traffic rate, which is neat. You can manage routing protocols, which is cool. Obviously, this is a home router, so I won't really need routing protocols. DHCP is not enabled, which I find very interesting because we somehow grabbed an address. I'm actually pretty confused about that. Let's add a DHCP server since we want one. So this DHCP server is going to be home DHCP subnet 192.168.0.1/24. Oh, 0.0/24. So range start 192.168.0. Do we want to allocate any static addresses? I'm not going to right now. We'll start this range at, actually our router's 1, so we'll have to start the range at 2, and then it'll go all the way up to 254. Router is 192.168.0.1, which is what we're on right now. And let's set our DNS servers as well. I do use Google's DNS servers because they so far have committed to not filtering those in any way or monitoring them in conjunction with their other services. Just clean, unfiltered DNS, which is what I want. And we don't have a Unify controller, but we will enable this DHCP server. So I'm going to click save on that. CPU usage went up a little bit when I did that. That was interesting. And so now I'm gonna disconnect and reconnect. Oh, and I was connected to the wrong network. That was the problem. See, when I tried to connect to DHCP all, which would have tried pulling a DHCP address from the router, this is why I was so confused, because I hadn't set up DHCP yet. And now I'm disconnected from the network, so it's telling me it can't contact the device. When my laptop failed to get a DHCP address on this connection, it failed back to this 192 connection with a statically set address, which happens to use the same gateway. Very interesting. So now we can tell that this DHCP server is working because I can click DHCP all, and that connected up this time. And we're reconnected to our router, and now if I do an IP address, this time it was actually pulled from a DHCP server. All right, I'm glad we figured that out because I was really confused about how I was connected the first time. So that's great. We've got DHCP on our internal subnet. And at this point, I am going to run that speed test again. I'll go ahead and do it from the laptop. The speeds were the same between the desktop and the laptop. I am going to unplug my cable modem from the Cisco 1921 and plug it into Ethernet 0 on the Ubiquiti EdgeRouter 4. That is done. And so now if we go back to our dashboard, we should see Ethernet 0. It is connected. And let's see if it pulls an IP address. I may need to reset my modem because the MAC address has changed. I may need to do that. I'm gonna go ahead and do that. So we've got my modem right here. I'm just gonna pull power from it and plug it back in. That's required when the MAC address changes. The ISP does that so that you don't have a bunch of devices plugged into a switch, plugged into your modem, not going through a router. So we've got a link again. It will take a moment for my modem to come up. And eventually we should see an IP address appear here that my modem will hand out. While that's loading, we will take a look again at the CLI. So before, the services section did not have DHCP under it, but now if we do a show configuration service, DHCP server right here. So I would have had to type all this out manually, but instead of typing it out manually, I just went ahead and did it in the GUI. And now we do have an IP address from the modem, all right? And I'm still seeing the online light blinking on the modem. We'll wait until it's finished. What else do we have in here? We do have network address translation. And honestly, I like that there's a GUI because I know how to do NAT in a GUI on iOS, but that's not always what I want to do when there's a situation that requires opening up a port. If I'm trying to get a server running or something, I'm going to be worried about that server. I'm not going to want to have to console in here and figure out the syntax for setting up NAT. It's very nice to be able to just come in here and set up. It's actually port forwarding is what we would want, and we could just add a port forwarding rule to go from outside to inside. So that's cool. So now we are going to go to speedtest.net again, and that has taken a hot minute to connect. Let's do ping 8.8.8.8. All right, so we may not have connectivity right now. I wonder, does the router know to route between those two? Your session is timed out. And I've just been reminded that I need to reset those passwords. Here we go. So before you saw a 192 address here from our modem. Now we've got our public address. I guess the modem, I don't know if the modem figured out that it's connected to a router, so it switched to the public address, or if that was just a temporary thing during startup. But we cannot connect to a website here still. Let's go to routing. Okay, so our default route is going out Ethernet 0. And I don't know how these routes got set up, but we know we're connected to Ethernet 0, we're connected to Ethernet 1 here. This is a loop back, and then our default route is going out Ethernet 0, which is what we want. We've got some wizards here. There's a basic setup wizard. This basic setup wizard includes the user setup. I will do that manually later. Let's take a look at the firewall, and is there a default firewall? No, there's not. Not without going through the wizard first. So we're still not getting replies to pings. Can we ping the router itself? We can ping the router. Can we ping the ISP's router? Ping 75.132. Let's see, what's our next hop? This is our next hop. Can we ping that? We cannot ping that, so that's our problem right there. I kind of feel like this was what was going on the first time that I switched what was plugged into the modem. I'm gonna hit the power button on the modem and it's blinking. Oh, I'm gonna hit it again for reset. All right, so I just reset the modem via the reset button in the front. So we'll wait for it to come up again. I'm probably gonna end up killing my internet entirely and having to call Charter with my luck. We can probably manage that user over here. Yeah, so this is where we'll set up a new user and I'll delete this default one. We've got an uptime listed for a user, which obviously isn't an actual uptime, but it's how long the users existed. So I will revisit this tab later after the video is over. And any second now, we should be getting a public address again. We can go back over and try speed test. All right, so now we've got our public address on Ethernet 0. Still can't ping our modem. Well, I can ping Google from the router, actually. So this is a routing issue. There may or may not have actually been an issue with the Charter internet here, but this is a routing issue because I can ping Google. This is consoled into the router, but then of course my laptop going through the router cannot ping Google. So let's see what's going on here in our routing. Routing, we've got our default route. Well, we know that we've got a route to Google because the router once again can ping Google. So how's our firewall and NAT look? Oh, we don't have NAT set up That's probably the issue. All right, so here's what we need. Right now, here's what's going on. Our computer is located at 192.168.0.2. Our computer is sending a packet to the router from 192.168.0.2 to, we'll say, 8.8.8.8. The router is forwarding that packet onto the modem. However, it's probably not making it past the modem onto the internet because the modem is receiving the packet from the router with the source address still set to 192.168.0.2, which of course is a private address. Everyone's homes use that, so if that goes out to Google, Google wouldn't know who to send that back to. They would say, okay, 192.168.0.2, well, that's not an internet address, that's a private address, so Google wouldn't know how to return that to the modem, so the modem probably isn't even sending it out. What we need to do is make the router send out our packet to 8.8.8.8 from the router's own address of 75.132.8.221 right here. So to do that, we need to configure a NAT rule. I assumed that this was set up automatically, but that was a bad assumption. So we're going to add a source NAT rule. This is going to be called internet-NAT. Our outbound interface is Ethernet 0, and we are going to use masquerade, which means we are using the primary address of the outbound interface. This is similar to NAT overload or PAT on a Cisco router. It is going to send everything from all other interfaces out Ethernet 0 using Ethernet 0's address instead of the source address from inside our network. For all protocols, save. And now if we come in here, now it works. Okay. Here I was sitting bashing on Charter thinking that it was their fault when really I hadn't set up NAT on my router. So now that that's done, let's reload speedtest.net one more time. Now keep in mind I'm still connected through a Cisco gigabit switch, but the router has now been switched out with our Ubiquiti EdgeRouter 4. So I'm going to click, actually we're going to change our server to be the same server we used last time. Now we'll click go. Let's see what kind of speeds we're getting now. If we're still not getting great speeds, then I might need to upgrade my switch, and we can look into that later. Oh, that is so much faster. Okay, so take a look at that. The Cisco 1921 router was what was limiting our speed. Our switch is perfectly capable of gigabit speeds. In fact, this is faster than I've ever seen this. That was 927 megabits per second down. Of course, our upload is still around 33, 35. But at least now we've got our full download speed in addition to our full upload speed. So we are now running on our internet at the full speed we're paying for. So that is incredible. The EdgeRouter 4 is very capable of gigabit speeds when performing NAT, making this a great router for homes that have gigabit internet. That's everything I wanted to show in this video. We've got the router, it's set up. I will of course be going back and changing the user and taking a look around the other parts of this interface. But this is my new home router. Take a look down in the description for the link to this product if you are interested in reading about it. Also, if you enjoyed this video or any of my other videos, consider becoming a Nerd Club member over at nerdclub.knots.co for just $3 a month. But that's all for now. I'm Jacob Kaufman, I'm the Nerd on the Street, and I'll see you guys in the next one. Bye.